Hello students, today we are going to start with the fourth part of chapter force and pressure. In the previous part we have discussed about the pressure applied by liquid, and now in this part we will discuss about the pressure applied by gases. Here you can see a rubber balloon, a tire tube and a tube used while swimming. All these are filled with air. If suppose we try to press them, and when on releasing they again regains their shape, means they again come back to their original shape. Why? Because the air present inside them they are exerting pressure on the walls of this rubber balloon or tire tube, and we know that force by area is equals to pressure, so they have some area. So we can say that these gases or the air present inside these tubes or balloon are exerting pressure on the walls of the container. If we make a hole on balloon or a tire tube, then the air starts coming out with a pressure, which shows that yes, the air or the gas filled in a container exerts pressure. Yeah, now the next topic is atmospheric pressure. As we know that the earth is surrounded by layer of air from all sides up to a certain kilometer, and this layer of air is called the atmosphere. Here the first figure shows the different layers around the earth, in which the first one is troposphere, then stratosphere, mesosphere, thermosphere and finally exosphere. As we can see that here the density of these air layers are shown by color. As we gradually move up, the density of air layer decreases. It means what? In troposphere the molecules of air are maximum, and in stratosphere it is less than that, less than troposphere. As we move uh, higher to mesosphere, thermosphere and exosphere, the amount of molecules of air continuously reduces, and up to a certain height, at a particular height, it reduces to zero. It completely reduces to zero. In the second figure we can see that the most of the molecules are present up to 300 feet. Above that the number of molecules is quite less. Okay, so this was about the distribution of air molecules in our atmosphere. Now let's see the definition of atmosphere. It says that the force acting on a unit area is called atmospheric pressure. Okay, now from where does this force comes? As we know that air has mass, so if air has mass, it is going to exert force, because everything which has mass is going to they exert force on the surface of the earth. So that force which is exerted by the air because of its mass on a unit area is called atmospheric pressure. Okay, to understand this we can consider a column. We can consider a column, a tall column up to a height of atmosphere can be considered, and the amount of air collected in this column will have some mass, and that mass will apply some force on the base of this column. Here you can see the base, okay, on the base of the column. So by the formula force by area, by using this formula force by area, we can calculate the pressure on the ground or on the surface of the earth. Okay, and the atmospheric pressure decreases as we go up in the atmosphere. For example, if we are climbing a mountain, okay, then the atmospheric pressure will decrease. Why? Because if we will go up, the amount of air our above our head or above our body would be less, and less. If the amount of air is less, the mass of the air would be less, so less would be the force, and hence when we go to higher altitudes the atmospheric pressure decreases. This is why the mountaineers or the astronauts, they have to wear a special suit to maintain the atmospheric pressure. it has been estimated that a force due to air column up to height of atmosphere and of area 15 by 15 centimeter, means on ground if the area is of 15, means if we are drawing a square of 15 to 15 centimeter, then the force applied by the air is equal to 2250 Newton. It is equal to 2250 Newton, or we can say that the air contained in that imaginary column would be of 2 to 5 kg, that is 225 kg. So this was the definition of atmospheric pressure, which is the force acting on unit area. Yeah, let's move to the units of atmospheric pressure. The SI unit of atmospheric pressure is Pascal, which is denoted by PA, capital P and small a. There are other units, that is bar, and the device that is commonly used for measuring the atmospheric pressure is known as barometer. Here you can see a figure of barometer. It has a needle which points at different numbers to give the value of atmospheric pressure, and it is usually used to measure the air pressure. Okay, and the value reduces to means the needle points to the small values when there is a storm, and in normal condition it points to the higher values or to the higher numbers. Okay, now usually they use these barometers use a unit that is millibar, which is denoted by small mb, and the relation between 1 millibar and Pascal is this, that is 1 millibar is equals to 100 Pascal. So this was about the unit of atmospheric pressure and the device which measures the atmospheric pressure. Now let's see what is the magnitude of atmospheric pressure or how strong it is. Okay, now it's given that this we had discussed that if the area is 15 by 15 centimeter, then the amount of air present in that column would have mass of 2 to 5 kg. You can calculate the pressure by using the formula force by area. You can use this formula to calculate the pressure applied on the ground. Now let's take an example of a sucker. Okay, means if suppose this sucker is pressed on a smooth surface, if it is pressed on a smooth surface, then the air between that sucker and that smooth surface is escaped or it is removed, due to which the air pressure inside that air sucker reduces, and on the from the outer side the pressure is more, and on the inner side the pressure is low. And because of this low pressure, this air sucker, it is permanently fixed on the, or it is fixed on that smooth surface. Okay, you might have seen various use of this air sucker in different areas. Now let's see what is the magnitude of the air pressure at different heights. Generally, for reference, uh, the air pressure used is 1 lakh Pascal. That is 1 lakh Pascal. That is the atmospheric pressure at the sea level. Okay, so it is the reference, that is 1 lakh Pascal, which is the atmospheric pressure at sea level. As we move higher, the atmospheric pressure keeps on reducing because the amount of air is reducing up to height of Mount Everest, that is around 8,850 meter. That is, it is almost near to 9 kilometer. Okay, it is around 31 kilopascal. It's around 31 kilopascal. That is 31,000 Pascal. And at the end of the atmosphere, it becomes zero. It becomes 0 Pascal. So these are the values of atmospheric pressure at different heights on Earth. Now the question arises that though it is applying so much of pressure on each and every object present on the Earth, then why we doesn't feel that atmospheric pressure? It is because our body also applies a a same amount of pressure in opposite direction to the atmospheric pressure. Means what it is doing, it is applying a counter pressure to atmospheric pressure, because of which our body doesn't crush under this atmospheric pressure, and we doesn't feel that yeah, some pressure is being applied on us. Okay, in this figure we can see that these arrows are showing the atmospheric pressure, while the arrows shown inside the body are showing the pressure applied by our body, which counters the atmospheric pressure. Okay, now it both the atmospheric pressure and the pressure applied by our body are equal when we are on the surface of the earth or near to the surface. But what happens if we move to an higher altitude, means on mountains? Okay, now if we will move on mountain, of course the atmospheric pressure is going to decrease, but our body pressure is going to remain same. So there will be an imbalance between the body pressure and the atmospheric pressure, because of which lot of mountaineers suffers from nose and ear bleeding, because an imbalance is created between the body pressure and atmospheric pressure. Now let's see what are the applications of atmospheric pressure. Okay, there are a lot of applications, but here we have discussed only two. The first is syringe. Okay, we all have seen syringe and how it is used. Okay, when the piston is pulled up, when it is pulled up, the atmospheric pressure inside the syringe decreases, due to which the fluid is filled inside this syringe. Similarly, when we are drinking any liquid through a straw, when we suck the when we try to suck the fluid, first the air present in the straw is removed, due to which the pressure inside the straw decreases, or the atmospheric pressure decreases, and this is the reason the fluid starts it enters the straw and we are able to drink that fluid. So these are the two simple applications of atmospheric pressure: syringe and straw. Okay, and you all are requested to find few more applications of atmospheric pressure which we use in our daily life, and comment uh, and do a comment in the under this video. Okay, now there are few worksheet questions for you. Just solve it.